Okay, 1.4, pulling a rabbit out of a hat. I have a magic trick for you. Pick a number, any number, add 6, then multiply the result by 2, subtract 12, divide by 2. The answer is the number that you started with. People are often mystified by such tricks, but those of us who have studied inverse operations and inverse functions can easily figure out how they work and even create our own number tricks. Let's start by figuring out how inverse functions work together. Excuse me. For each of the following function machines, decide what function can be used to make the output the same as the input number. Describe the operation in words, and then write it symbolically. Here's an example. An input of 7. 7 plus 8 is 15, and then the output is 7. So we input 7, and then we do something to leave us what we started with 7. So there's two things that we need to do for every one of these problems. What we need to do here is we need to find the inverse function of this. So remember, for the time being, I'm going to write y equals x plus 8. And then to get the inverse, I switch x and y and solve for y. So x minus 8 equals y, but we're all more comfortable when y is on the left. There is the inverse function. That's the first thing that we need to do. Now on the right, in words, you just need to say what you would do here to leave you with like 7 equals 7, okay? So in this case, subtract 8 from both sides. Right here is the thing that would leave you with 7 is equal to 7. Number 1, x is equal to 7, and then we have this, and then we have 7 again. So what do we need to do here to leave ourselves with 7 is equal to 7? We need to divide, these start kind of easy, guys, each side by 3. And over here we're going to have y equals 3x. Then we're going to have x equals 3y. Then we're going to have x over 3 is equal to y. And then just circle your answer. So here you'll have your shown work algebra. And over here we will have our sentence saying what we do to each side. Number 2, x is equal to 7. 7 squared is 49. And then we have 7 again. So we're going to have y equals x squared. We're going to have x equals y squared. Then we're going to have y equals the square root of x. And in words, well, what would we do here? What's the inverse operation of this? That would be square root. So I would take the square root of both. Take the square root of both sides. Okay. Number 3 is going to get a little trickier. And actually, now that I look at the answer key a little bit closer, I want to do a better job of writing our answers. So before we get on to that tougher problem, I'm going to make a correction here in pink. So we want to get in the habit of writing the answer as f negative 1. So the inverse function of x is x over 3. The inverse function of x is the square root of x. That's how we need to get used to writing those. Okay. Number 3. Okay, so for number 3, I've probably already paused the videos and told you a little bit about basic logarithms. But here, what we're going to do is we're going to have the inverse function of x is equal to logarithm 2 x. Okay, so that, remember, over here is what the exponent is. So it would be like 2 to what power? Like if I were to fill this whole thing out, which we don't have to, it would be 100, it would be 7 is equal to log 2, 128. And then remember, it goes 2 to the 7th power is 128. Okay, so this is our exponent, and this is our base number, and this is your answer. So, yeah, and you can also just write your answer there. Obviously, you guys have probably already picked up on that. Okay, so what would we do to both sides? Well, I would undo the exponential with a logarithm. Okay, next one. I think you guys are going to be fine on this on your own. So some of these easier ones I don't think I'm going to have to do. But I do want to do one like 6, okay, because 6 gets to be a little bit more advanced. So let's start with solving for the inverse. So we're going to have y is equal to x take away 3 squared. So our inverse is x is equal to y minus 3 squared. And then I'm going to take the square root of both sides, and I will have the square root of x is equal to y minus 3. And then I'm going to have the square root of x, basically. Add 3 to both sides, plus 3. So that is the inverse of my original function. So in words, what did I do? Well, what I did for number 6 was I took the square root, then added 3. Number 7, okay, for 7, also a little tricky, so I will be doing that one as well. It's trickier than the last problem for sure, and I'm curious to see if anyone had the algebra skills to get it. So I'm going to start just like all the other ones, okay? So I'm going to have okay, so what I've done so far is I subtracted 4, okay? Well, I switched x and y, and then I subtracted 4. Now, what makes this problem tricky is the negative y. So how do we get rid of a negative y? Well, we multiply by negative 1. And when I multiply by negative 1, this is a long problem, so I'm going to have to go up here. I'm going to have negative x plus 4 is equal to the square root of y. And then I need to square the entire quantity. So don't write this, but I'm not going to say this is wrong, but it's not nearly as good. Okay? What we want to do there is we want to switch it. I think just as a rule, guys, whether it's quadratics or most things, it's helpful when that first term is positive. So I'm going to write this as the square root. Well, what's an expression I could write equivalent to this one, where the first number would be positive? And that would be 4 take away x is equal to y. Okay? And that is the inverse of that one. So really quick, I want to plug these into Desmos just to talk about what happens. So I'm going to have 4 minus x, let's see, 4, shoot, I forgot. The square root of 4 minus x, okay. So we're going to have the square root of 4, take away x. Okay, there's our graph. And then we're going to, 4 minus x squared, excuse me. So squared. Okay, so linear. Now I'm going to do the original function, which was what? The original function was 4 minus the square root of 7. Why is it not graphing that? Okay, y equals 4 minus the square root of 7. So we can see that this is going to reflect over the line of y is equal to x. It does closely, let's see. What happened there? 4 minus the square root of x. Oh, that I put in 7. Oops, sorry. Okay, see, I knew that I had made a mistake because my graph did not reflect over the line y is equal to x. So remember that y is equal to x. I can't draw on Desmos. I wish I could right here. But that is just like starting from the origin and counting up 1 over 1. Imagine there was a line going diagonally right, keep drawing like it's actually going to do it, but right through the middle. So that would, the red one would reflect onto the blue one and vice versa. That's how you know you've gotten the right answer with an inverse, because that is the relationship that they have. Okay, number 8. Number 8, we are going to solve for the inverse first. So we're going to have y is equal to 2 to the x minus 10, and then we're going to have x is equal to 2 to the y minus 10. And then we'll add 10 to both sides, and we'll have x plus 10 is 2 to the y. Okay, so we got to write this as a logarithm. So remember, with a logarithm, we're going to have log, and then you're going to have the base number, which is 2. And then really big, kind of written like on the same line as logarithm, you're going to have the answer, which is x plus 10. And then it equals the exponent, which in this case is y, or, so what did we do to both sides there? Well, we added 10, then used a logarithm to undo the exponential. Okay. Number 9, each of these problems begin with 7. What is the difference between the x and the f of x and the x of x minus 1? So basically the x is used in f of negative 1 as the output, or the y value of f of x. Okay, so the x that is used in the inverse of x is the output of f of x, meaning basically they just switch. 10, in number 6, could any value of x be used in f of x and still give us the same output of f of x minus 1? Okay, so basically what we're talking about here is what is the domain for number 6? What numbers can we use given that it is a function? So if you go back to number 6, which is this right here, well, what x values are allowed? Because some of them are like forbidden, and you're not able to use them because it would break math rules, okay? So in the first one, and you guys can be writing the answer down on that other blank, but in the original one, the only values that work are x has to be greater than or equal to 3. Okay. Let me make sure that's correct. Only positive numbers can be used as inputs for f of x. Okay. So let's look at what was our final answer for this one? Our final answer was here. Okay. So here we want only positive numbers. This is really what we need to focus on, because here I started thinking about it. It's like, okay, well, what if we were to plug in negative numbers? There's no square root that's a part of this one, right? Our range would be limited because the only thing that we could get for y would be positive numbers. And just like over here, we can only have positive numbers, but for the other side, so here, y could only be positive, but in the inverse, x can only be positive because we can only take the square root, unless we're using imaginary numbers, of positive numbers. So however you want to summarize that is fine. Okay? Based on your work in this task and the other tasks in this module, what relationships do you see between functions and their inverses? So I'm just going to pop the answer key up here in a second. If you're watching this from home, you can just pause the video. But let's see here. So answer key. There's everything we just did. And then here are some of the relationships. A function and its inverse undo each other. There are inverse operations like addition, subtraction, multiplication, division, squaring, square rooting. Functions and their inverse use these operations together, and they need to be in the right order. For a function to be invertible, the inverse also has to be a function. We talked about that the other day. And the domain of a function can be restricted to make it invertible. Okay, so the really excellent example of invertible was this. Where did I have it? Actually, maybe I have it in Notability. Yes, I think I do. So I will probably pause the video and find it on here so you guys don't have to watch me just kind of fumbling around for it here, unless I can find it now. Okay, so I'll put that up on the screen and we can talk about restricting the domain to make that happen. So that is it for the video. So your homework is RSG. And just glancing over that, let me see if there are any major issues that I want to talk about. Exponent rules become very important. Remember this section, you're adding, if they're the same base number, you're allowed to add. So 6, for example. This would be, you got to go 6 plus -3 plus 1. So this would be 2 to the 4th. And then when you divide exponents, you subtract. So this is 3 to the -3rd, which is 1 over 3 to the 3rd, which is 1 over 27. For 11, it's a little trickier. We have -4, subtract a -8. So this actually becomes 7 to the 4th. And generally, as a rule, if the number multiplies out greater than, I don't know, like a few hundred, you can just leave it as 7 to the 4th, because that's going to get pretty big. This is what we did in class today. This will be really good practice. And then you're going to have to go down here and solve these. And if you guys have a problem with the go, maybe I'll talk about the go a little bit at the end of the period, just to kind of see how we're doing with that. But I think that gets you a very good start in the way that the task is almost finished, and that'll be